Okay, well, I think we've given everyone an opportunity to join. So thank you very much for joining us today. This is the second consultation workshop that we're running for the CertiCAV project. I should just mention that this meeting is being recorded and the video will be available online afterwards. My name is Zane Seigel. I'm the technical lead for the CertiCAV project, and I'm going to give you a quick introduction to the day to start with. What we're interested in is assuring the safety of CAVs, connected and autonomous vehicles. And why do we care about this? Well, firstly, because nearly 32,000 people every year in the UK are killed or seriously injured on the roads. And we think CAVs can reduce that number significantly. Secondly, this £900 billion potential market size for the CAV industry. And safety is a blocker for this industry. Once we sort the safety issue, it enables organisations to fully take advantage of this potential market. So on CertiCAV, we're working for the Department for Transport in the UK, so we have a regulatory focus for the work we're doing. We're also part of the CAV Pass programme, which is run by CCAV, the Centre for Connected and Autonomous Vehicles. The project is being run by us at the Connected Places Catapult, and I'm delighted to say we're also running the project in collaboration with WMG at the University of Warwick, with a team there led by Siddhartha Kaskia. The goals on the project are to develop thinking and understand the options for safety assurance of highly automated vehicles. So we're focused on level 4 and above. We're also aiming to demonstrate some of the safety assurance process in simulation. Our scope is perception and tactical decision making. We're excluding cybersecurity, functional safety, and operational and in-use safety assurance issues. This project is building on work we did previously on the music projects, where we created a scenario database to capture certification scenarios for use in regulatory assurance. And this project enabled us to gain a lot of knowledge about the ecosystem and the challenges involved, and we're deploying that on CertiCAV. The system is also available as open source code. If you're interested in it, then please have a look at the link here. Okay, so what we're really aiming to do today is firstly to give you an overview of our thinking on safety assurance, and then most importantly to get some feedback on these ideas and how we should develop them throughout the remainder of the project. So on Zoom you should have a Q&A button at the bottom. Please feel free to ask questions throughout the event, and we have a couple of panel sessions coming up where we can address all those questions. A bit of a disclaimer that it's a fast-moving area, as everyone is probably aware, and we're presenting provisional ideas today and the eventual findings that the Catapult and WMG come up with may well differ from the things that we're sharing today. Okay, to quickly go over the agenda. Next up, we have a keynote from Mike Brasher at the Department for Transport. We have our first technical session from Tom Webster looking at assurance requirements. Conor Champ from the Law Commission is going to give us a guest talk on their upcoming consultation work on AVs. We have the first panel. We're very happy to have Mike Brasher, Graham O'Brien from the DPSA, Eric Barbier from WAVE, Siddhartha from WMG, and Connor on that panel. We are having a 10-minute break in the middle of the session, and then we'll restart with Rob Myers talking about our software toolkit and demonstration activities. Siddhartha will talk about the work WMG is doing, starting with the scenario generation process. And then we have our second technical session where Tom's going to talk about the assurance process and the goals and relationships involved in actually checking that the system has reached the required level of safety. Following that, we have our second panel. Again, I'm very happy that Tim Edwards from Hariba Mira will be joining that, Camilla Fowler from TRL, Matt Claydon from the VCA, Vehicle Certification Agency, and Ian Whiteside from FIVE. Okay, with that, I will hand over to Mike to give us a keynote talk.
Hi, yeah, thank you, Zane, and good morning to everybody. Just please bear with me whilst I make sure I share the screen. Thank you. Yeah, so for those of you who are not familiar or have not met me, my name's Mike Brasher, and I head up the innovative mobility team within International Vehicle Standards within the Department for Transport. And I'm delighted to be able to come and give a keynote speech on this second CertiCAV workshop. So when I was asked to do a keynote speech, I started thinking about what I'd like to say and how can I put CertiCAV into some kind of perspective as part of the government's sort of overall ambitions on automation. So with that in mind, Zane's already touched upon some of the benefits that automation can bring. Of course, the challenge, as we all know, is ensuring that we can realise all of these benefits and that we do so safely. So within government, we're fortunate to have 4 teams working together to ensure that we can indeed realise these ambitions. We have the Centre for Connected and Autonomous Vehicles, or CertiCAV as it's known. And CertiCAV are leading on the future of transport strategy. And you're probably familiar as well with the CAVPASS project, which launched in 2019. So CAVPASS stands for Connected and Automated Vehicle Process, assuring safety and security. International Vehicle Standards, so that's me and the team that I sit in, and we have expertise in sort of vehicle systems, regulation and type approval, and we are looking at some of the processes that are needed to enable safe and secure deployment of innovative technologies, including automation. The Vehicle Certification Agency, so again, very important that the agency responsible for type approval has, can contribute their significant expertise in type approval and can ensure that any processes that are in place are implementable. And then the Law Commission. So today's session is jointly hosted with the Law Commissions, actually, for England and Wales and the Scottish Law Commission. So you may or may not be aware, but the Law Commission have been undertaking a 3-year review of approaches for regulating automated road vehicles. So we've got the expertise, we think, and we're working together to try and figure out how the UK can realise the potential benefits of automation. So how does CertiCAV fit in? Well, I mentioned CAVPASS, the initiative that was launched last year by the Centre for Connected and Autonomous Vehicles. Broadly, we think of CAVPASS in sort of 6 key work streams, from looking at vehicle technical standards and how we develop assessment and approval methods to complement the technical standards. Safe use, we think, for automation takes on sort of greater focus and importance. And then, of course, it's very important that we have the skills and facilities within government, but I guess also within the UK to promote and deploy automated vehicles. So it's really, where does CertiCAV fit in? Well, CertiCAV was a project that DFT initiated to help inform our thinking around the vehicle technical standards and how we can assess the performance, safety performance of automated vehicles. So, as you're all aware, the project runs until next March, and we're very looking forward very much to see what the Catapult and WMG finally present to us. So this is the second CertiCAV workshop. As I said, it's jointly hosted by the Catapult and the Law Commissions. And really, it's an opportunity to contribute to the thinking on safety assurance of automated vehicles. So I'm very much looking forward to the discussions and the 2 panel sessions that we have lined up. So with that, I'd like to thank you all for your participation, and I'll hand back. Thank you.
Great, thanks very much, Mike. Next, I'd like to hand over to Tom Webster, who's a principal technologist here at the Catapult and is leading the work package on developing an assurance system as part of CertiCAV.
Yeah, I'm just bringing up my and you can see me as well, but the slides are the important thing to see. So yes, welcome everybody. I'm Tom Webster. I'm talking to you about assurance requirements today. So just to reiterate, this is kind of what our scope is for CertiCAV. So if you kind of look at it in terms of like an overall technical framework of processes and practice, we're kind of covering this kind of like machine learning kind of perception and behavior side in terms of kind of the practice and on the processes. We're covering the V&V and licensing approvals and a little bit of a common definition and other things. And this last goal here is kind of one that's a bit specific to this presentation. So we're kind of trying to develop structured and reasoned requirements. So just a bit of general background here, like the general approach we're taking for CertiCAV, this is a repeat from the previous workshop, is that if you look at how the technology overall develops in terms of actual on-road deployments, and you kind of have a general timeline going from short-term to long-term, you start off with, based on the current code of practice, you do a consultation, and then you can deploy on the road, of course, with human driver having responsibility, and then suggest that okay, well, if you're now going and actually doing wider service demonstrations, that you perhaps want a bit more assurance there, and so some acceptance testing gets involved in these advanced trials. And then when you go further afield and then you're truly maturing things and actually really removing that human from the responsibility chain, then you're now talking about actually licensing that, similar to how a vehicle platform is type approved, but it's covering both the kind of the driver license and the vehicle license aspect of things. So then there's quite a lot of assurance things that need to be covered. And how that relates to our general approach is that we actually see step one is to put some initial definition on what that final system of licensing looks like, and then draw out of that and then pull that into step two. And the reason for doing that is you want what you implement in your advanced trials and the learnings that come out of it to be able to feed into and further develop your licensing system. And so if it's a completely different system, then you're not going to get that learning and refinements. You need to have some understanding on what your final picture is, so that you can get the best development out of your trials. And then just to look at the general context of CertiCAV and what we're looking at, what we're trying to address with these requirements is, well, if we have here this in green, we've got a EGO vehicle, which is a highly autonomous vehicle or highly automated vehicle that's installed with an automated driving system. It's performing the driving task in an ODD. This is the general context of what we're covering. So that's the deployment that we're kind of looking at. So we're looking at level 4 plus automation, where you've got no human fallback available. It's quite a wide scope in terms of, yes, deployment on public roads, maybe mixed with human actors, wide-ranging ODD, including urban driving, fairly wide range of vehicle in use case. And then, of course, there's various stakeholders involved when you are deploying on the road. It's not just a vehicle working in isolation. It's interacting. There's various different organizations involved. So first of all, just kind of why are we considering assurance requirements? You need to have some definition on what sufficient safety is when you're developing a system to actually implement that assurance process. So that these two things are symbiotically linked. How you define the requirements has an impact on how you actually then implement a process of assuring that requirements are met. And there's two areas of requirements that need to be addressed for HAV. So there's organizational requirements. So what is required to facilitate the organizational activities that are involved in deploying a vehicle on the road autonomously. And then another completely different set of requirements is the performance, what is required from the actual performance of the vehicle so that it's actually operating safely in the environment. So looking at the organizational one first, the first thing we identify is that because there are these various stakeholders that are involved in the safety assurance of the HAV deployment, that the deployment itself needs to be sufficiently well defined and specified so that all those different stakeholders have an understanding of what's involved and support them to fulfill their role. So the kind of things we're talking about is that, of course, you've got the system developer who's produced that system and is, of course, owns the safety case. You've then potentially got a HOPS operator. Just to note that this terminology is aligned with the consultation too from the Law Commission. You've then got regulators and authorities who need to regulate and manage all these deployment activities. And there's different authorities there. So you might have a local traffic authority who's maintaining the road network, and different authorities who are involved in the licensing and so on and so forth. You've got sort of technical service, testing, inspection, certification bodies who are involved in doing independent assurance. You've got insurers, they need to insure the vehicle, and then you'll have various service providers. So with all those roles and tasks that are being done as part of this deployment in mind, we identified 5 key areas that need to be covered by a deployment specification. So the first one is the vehicle operational characteristics. So the outline physical and use specifications of the vehicle have a pretty big impact. So if you have a small pod with 2 occupants and they're seat belted, how this kind of overall affects safety in particular scenarios is going to be very, very different to if it's an omnibus where people aren't even secured by seat belts. These use and outline physical factors have a very big impact on various aspects. Then, of course, there's the operational design domain. I don't think I need to explain that one that much more. Everyone knows about operational design domain. There's what we at the moment are calling ADS functionality. So the operational design domain is, of course, the environment that the vehicle is operating in. ADS functionality is what we're currently calling how the vehicle actually operates. So we're kind of putting in there not just the behavior, its intended behavior. So an important part of the ADS functionality is how it's intending to maneuver and operate in the environment, because it could be, for example, perfectly legitimate, in particular if it's kind of like a delivery robot operating on the road, to say it's only going to stick to the near side lane and do left turns. And then that restricts things and enables things to be argued safely. Whereas if it's changing lanes and going in and turning right and got a much more diverse behavior, a lot wider system of things needs to be taken care of. But then we're also then saying, well, that what its perception capabilities are is part of that ADS functionality as well. You've then got the deployment system architecture. So are there offboard systems that are involved in safety? Though there needs to be some definition of that. Positioning systems, it could be that there's mapping that is not kind of cached on board the vehicle, but is being pushed over telecommunications, cooperative intelligent transport systems, remote monitoring, or even potentially kind of an extension concept of having teleoperation. So there needs to be some understanding as to what offboard systems, that what the wider architecture that's involved in this have in this deployment, so that things can be managed appropriately. And then the last one is deployment management. Now, we don't want to go deep into, because we're not covering in use factors, but how, if the road layout changes, how is it made sure that the behavior of the vehicle is safe? What processes are in place to manage that? And what is done in terms of deployment management in terms of making sure that there's an understanding of the operational conditions. So it's one thing saying that your ODD is that you don't operate in rain, but what does that actually mean in terms of its actual impact to your deployment? Because it's one thing to say, okay, your vehicle stops when it doesn't rain, but is that actually in the real world practically going to work? It depends on various aspects of how your deployment is specified. And then the other part of this kind of organizational requirements is then common system definition. So if we just talk about that there's an ADS on a highly autonomous vehicle, that's not quite enough to put definition on the deployment specification and all the various things in the assurance process. So we have tried to kind of outline a very bare minimum. So we suggest that it needs to be explained, these different aspects. So perception, in very general terms, what is the view and range of the sight of the vehicle? What type of objects and events does it detect and respond to? So depending on where it's operating, different things may or may not be acceptable there. Live data sets, so what kind of data is used for validation evidence, and what interface might be available for testing perception. This we kind of talk about later. So what options are there for testing that may mean that it's less expensive to go about doing testing? How is there, so that this relates back to what you can see how this relates back to various parts of the deployment specification. So there's ADS behavior. How is the HAV intended to maneuver and act in the environment? And controls. So what is an emergency stop? So what are the intended characteristics for the lateral longitudinal actuation of the vehicle? And non-motion stuff as well. So is there some kind of visual interface that's being provided? How is the vehicle controlling lights, indicators? Does the behavior include operating the horn, and that kind of thing? And then the data communication, so that's linking in with the wider system architecture. So what safety critical features involved off vehicle systems that, through data communications? So that's kind of very top level stuff on organizational requirements. We then get to the actual more tricky part of performance requirements. So one way of talking about that is if we start off with core kind of safety assurance practice, so the kind of the processes involved. I've got functional safety and SOTIF here, and there are of course a lot more processes, but this is just what is directly within the scope of CertiCAV. And then of course, feeding into the SOTIF, you need an intended functionality specification. So adaptive cruise controller AEB, that has its own standard defining what the functionality of that driving function is. So at the moment, for kind of type approval exercises, there's the national and international vehicle requirements for type approval, and then that currently the intended functionality is prescribed by deterministic specifications, and there's this kind of relationship that you tend to have an ISO that will define that specification, but then there's in the actual regulatory technical framework, there's then a description of it as well. But now if we look at level 4 and we look at the vehicle being completely responsible for the driving task, all sorts of other regulations come in. Now it's having to actually really take over for the driver. So you've got driver licensing and all the road traffic rules and everything involved. And you've got the Automated Electric Vehicle Act. Not all of these necessarily are now going to be covered by requirements in the form of specifications. It's also possible that due to this much wider remit, that some of the requirements are set as being targets. And so these are kind of treated in quite a different way. I think it's easy to forget when you work in automotive that the regulations are, in terms of the system performance, it's pretty much all specifications. And you need to kind of go over to aviation domain or something to then actually find examples of where you have targets as requirements. So these are things that relate to the validation and are probabilistic in nature, rather than relating to being deterministic requirements that are relate to verification activities. So then perhaps because for this higher automation level and the wider ODD and the functionality covering a much wider remit, it's impractical to prescribe this with to prescribe the functionality. So if you go, Alex is already kind of creaking at the seams in terms of going through, continuing the process of defining all the functional scenarios and intended expected behavior in all those functional scenarios. When you make things wider than that, you can no longer identify, you can't draw out a list of all the functional scenarios when you get pedestrians and bicycles involved and all the other aspects. So then what in some quarters people are talking about is this field of behavioral safety, because you've no longer got this distinct definition of your intended functionality. You now need to have a process to develop the intended functionality for your particular use case, and verify and validate it. And that has now got things like driving regulation feeding into it. And then operational safety is now part of your overall, needs to feed in formally to your quality management system, because your system is going to be responsible for fallback operation. So then the question is, well, okay, where does all this stuff feed in? Is it what is feeding into specifications? What's feeding into targets? How are these things defined, and how is it all managed? So yeah, just reiterating again that when you look at this vastly more complex systems, you can't continue prescribing the functionality. But then, so you need to define your requirements at a higher level rather than doing these prescriptive requirements. But this is far from trivial. So if you kind of take a kind of a law type requirement, drive carefully and competently, well, how do you measure that? That's not kind of verifiable technically. Comply with road traffic regulations, or even at the expense of avoiding a collision, and how is, again, technically, how do you actually measure compliance when quite a few of these regulations are not objectively specified? This is from UNEC. So do not cause any traffic accidents resulting in injury or death that are reasonable, foreseeable, and preventable. What is reasonably foreseeable and preventable? This one's in a different color because this is kind of like a statistical one. Okay, make sure your casualty rate is at least 20% less than human drivers. So is that even when you are completely not at fault, and someone's completely recklessly crashed into you and there's nothing you could have done, and how many billion kilometers of evidence do you actually require to evidence this? Probably about 11 billion kilometers or something to that effect. So for requirements to be viable, what they need to do is they need to define acceptable safety, of course. They need to refer to measurable performance indicators. So this last one, okay, this one is measurable. But the others have some problem with actually being measurable in a technical sense. Targeted, structured, and implementable in assessments. So this last one, however, it's very broad brush, and then there are technical challenges in actually creating the body of evidence to actually argue that one. And they do need to be free of conflicts, well, especially ideally. Things like saying comply with road traffic regulations and then having one saying don't cause traffic accidents. It's possible for if a lot of care is not taken, these things can actually conflict with each other. So we attempt to develop requirements that satisfy this based on a structured process. And just a few thoughts to bear in mind. So part of the challenge here is that things that the requirement needs to cater for is that this is a system, an automated system that is fitting with an existing system of governance and infrastructure that's evolved over time for human use. So it's not intended, it has the system of road traffic regulations, it's evolved over time as something that works for humans, but it's not validated for application to automated systems. It's a multi-agent operational environment. So just coming up with behavior that from an egocentrical sense is safe isn't quite good enough, because it's interacting with our agents, and those need to be positive interactions and understood. And there's quite a lot of kind of local conventional sorts of things that can occur. It is a high risk operational environment. It's been a while since I checked, but a while ago, road traffic deaths worldwide, I mean, admittedly, predominantly from the developing world, top 10 cause of deaths in the world. It is risky. Tactical safe, when you go into level 4 systems, you need to take care of tactical safety in addition to active safety. And it's complicated, there's several layers of complication. And just to explain that second to last point, so if you kind of take the archetypical automated risk assessment system, where its risk is the formula of exposure times controllability times severity, when that's kind of applied to functional safety, the exposure is taken as a given quantity, because the human who's driving that vehicle has put it in that situation. But when your automated system is now becoming truly responsible for the sustained driving task, it now has control of that. So that's what we call tactical safety, is what controls your risk exposure. You've then got active safety, and there's plenty of active safety systems that are putting controls on the controllability aspect of risk, and then you've got passive safety that's managing the severity. So something that needs to be taken care of is that these higher automation levels and more complex functionality, you are now in control of tactical safety, and that needs to be taken care of and calculated in risk. So the process that we've kind of put together, this is a bit abstract and a bit hard to get across, but is that we start off with a kind of identification phase of, we put together driving criteria, which is a superset of all the things that are statements that are describing adequately good driving. But you have issues. We take note of issues that there are in the application of those to kind of like an assessment process, to developing rationalized requirements. And we define a common kind of type of safety performance indicators so that we can consider how those can be applied to describe requirements and to implement assessments. We then go through this kind of assessment process of taking all those things and going through thinking through what all the pros and cons are of all the different options, applying those to each criteria, and then that then goes through a consolidation process, and we start to get some structured requirements out of that. So the reason that we're doing this is that we're trying to develop a compromise for requirements that not only provides a good enough definition, a solid enough definition and a good enough control of safety, so that what is safe enough is adequately defined, but it's also able to provide assurances practically when implemented to independent assessment tests. So, for example, if you kind of take the kind of the statistical argument, it's quite easy to say, yeah, be X times safer than current casualty rates. But to actually get an assurance in independent test type situation for that, you can't get the you can't get the coverage of the test cases in order to actually validate that kind of statistical argument. So yeah, so this assessment is a kind of like a what if assessment that's kind of trying to work out what are the so just to say, so the criteria we've identified are these 8. So the intention here is to come up with as good as we can, but there's a kind of a process here. There's an actual algorithm behind this in terms of, okay, if new candidates come up, those can be added in, and then that can then go through the process again. And then the kind of issues that we've identified, so that you have overlaps between those criteria. So the criteria statements that they all have a unique aspect to scope, but they do overlap with each other. So if you obey traffic rules, you are to some sense making sure that you don't collide with people, that you're not providing guarantees of that. So there's overlaps, there's conflicts. Not unreasonably obstructing movement of traffic can potentially conflict with following traffic rules or providing reasonable safety margins. So you're turning right out of a junction. If you follow the road traffic rules strictly, you should wait for a gap that's sufficient such that you don't require anybody on that major road to have to adjust their course or speed. But practically, it's not always possible to do that. So on and so forth. This is what the safety, the 5 categories of safety performance indicator are that we've identified, and again these can be added to. So you've got incident occurrence, which is your classical kind of statistical performance indicator. Risk calculation, which is kind of the surrogate safety type indicator, so quite often implemented in ADAS features. Observed behavior quality, which is kind of a bit of kind of what is traditionally used to evaluate driver comfort, but also on the other side can be used as part of kind of dynamic vehicle dynamics assessment in terms of grip circle and that side of things. Performance specifications, so there you've got RSS and safety force field, so on and so forth, or just and then you've got highway code conformance. So there's a difference between highway code conformance and performance specifications in that highway code is not always is more of a subjective judgment and is not objectively specified. So this is what the assessment process looks like. I think I'm running out of time, so I'm speeding up. And we then end up with this horribly complicated table, which I think if there's time later, I can go back to. But the end conclusion that we come out from this is that what this is about is what the roles of indicators are. So it's not about choosing an indicator, but what roles they play in the grand scheme of things. And there's a good general compromise there in terms of that if you increase the granularity of your evaluation metric, you can reduce your sampling size, but that has some overhead in terms of development efforts involved in validating that metric, and also introduces potential error, and that what we're intending on outputting from here is that there are some options that we can present on structured statements defining requirements and general boundaries of what are acceptable values for those statements based on kind of literature and data sources. So apologies, a bit hurried at the end, but I didn't want to go too much over time.
Great, thanks very much, Tom. Okay, now I'd like to introduce Connor Champ, who's a lawyer at the Law Commission, to talk to us about their upcoming consultation paper. Connor.
Thanks, Zane. Hopefully everyone can see my slides. Yeah, so as introduced, I'm Connor. I work at the Law Commission of England and Wales, and I'm a lawyer there working on the Automated Vehicles project. I'm here today to talk a little bit about our work and to tell you about our upcoming consultation paper, which we're calling a regulatory framework for automated vehicles. It will have a very, very large focus on safety assurance, and that's why we think it fits in nicely with this workshop today. Now, many of you probably already know who I am, and you probably already know who the Law Commissions are, but for those of you that don't know who the Law Commissions are, there are two of them working on this project. There's the Law Commission of England and Wales, which I belong to, and then there's also the Scottish Law Commission, who we're working with. And we are what's known as statutory independent bodies. So we're basically civil servants, but we're independent from the government. We're arm's length. And our basic task is to ensure that the law is kept up to date and to make reform proposals when necessary. So we tend to do things like take a look at old bits of law surrounding things like weddings or perhaps leaseholds, which hasn't been updated in a very, very long time. What we do is we consult on it, we research it, and then we come up with proposals that hopefully work for everyone and improve the law for everyone. Now, about 3 years ago now, CertiCAV came to us and asked us to review the regulatory framework of the UK in relation to automated vehicles. So to see what needed to change, what perhaps was good, or what could be done differently. And so we started our 3-year project on automated vehicles. We've done 2 consultation papers thus far. Our first consultation paper came out in 2018. That was on safety and legal accountability, very much scoping out the major issues in those areas. Consultation paper 2 came out last year, and that concentrated on automated passenger services and public transport. So looking at vehicles that perhaps can travel around empty, pick up passengers and drop them off. And looking also in the context of those vehicles, how they might fit in with public transport, so how they might be used for public transport or be integrated so that they don't detract from public transport. This year, we've been looking at bringing all of our proposals together. So to look at all those major areas and then bring them together, and then also particularly focus on the safety assurance framework that needs to go in place and how you would go about doing that in a regulatory sense. So that's why we're calling it a regulatory framework for automated vehicles. It really is outlining a lot of how a potential regulatory framework might look. And I should preface this by saying all of our proposals are proposals. They're things that we will put forward for consideration next year in our final report. So we must lay down our final report in front of Parliament, and they'll consider our final recommendations. So that's who we are and what we do and where we're at in our project. As I said, we're currently working on our latest consultation paper 3, and this has a number of key themes. So the very first thing that we look at is what exactly is a self-driving vehicle. If you're going to regulate self-driving vehicles, you want to know what is considered a self-driving vehicle. So we consider what is the meaning of self-driving and how do you define self-driving vehicles. We then look at safety assurance before deployments, looking at what sort of regulatory scheme you might want to put in place for assuring the safety of vehicles, or how you might purpose the current regulatory system and approval process for the approval of automated vehicles. We're looking at safety and use as well, so trying to understand what sort of checks and balances you need to have in place to look at the ongoing safety of automated vehicles, to basically check once they're on the road that they are performing as intended and that they are performing the way that the approver thought that they would perform. Going on, we look at user and fleet operator responsibilities. So if I own a vehicle, an automated vehicle, or I'm a fleet operator, what are my responsibilities? And tied up with that are issues of civil and criminal liability, which we also talk about at length. Now, rounding out the paper, we also talk about data, or more specifically, access to data, because we think it's going to be very, very important that the relevant data goes to the relevant parties if you want to do things like decide civil and criminal liability. So if an incident happens, you want to be able to get the appropriate data so investigation can happen, and that data needs to go to the right parties. Obviously, there's data protection laws and things of this nature, and these also need to be considered, but we're looking at all of that in the context of automated vehicles. Another thing that's important about data is you might also want it for the safety assurance process. So if something happens with an automated vehicle, you might want to take that data and feed it back into the assurance process so that the assurance process gets better, that the regulator knows what to watch out for, and that they know the potential issues that are happening out on the road. So we look at data in that context as well. So as I said, the very first thing we do in this paper is look at the meaning of self-driving, and that's because you want to know what you're regulating. You want to know what vehicles are considered self-driving for the purposes of the law. So the very first thing we do is look at automated lane keeping systems in this paper, and that's because potentially they are the first example of self-driving on our roads. They have been talked about as the first self-driving systems by a number of parties. So we're looking at them in this paper. As most of you may already know, the UN has a regulation now on automated lane keeping systems. So you could be seeing these systems as early as spring next year. And CertiCAV also have just finished, they've just finished collecting evidence for their call for evidence on ALKs. And they will be analyzing those responses. And they ask very important questions about how ALKs should be treated and how they might be, questions related to how they might be treated by the law and by bits of regulation like the Automated and Electric Vehicles Act. We will be also reflecting on the responses to that call for evidence. We're obviously working with CertiCAV, and we will reflect on that call for evidence and the things that they find out in that call for evidence. So we talk about ALKs a lot just because they are a very important example that's on the horizon. We also talk about the meaning of self-driving in the context of the SAE levels. So what does it mean to be self-driving, in the SAE classification system? We're looking at it in the context of human factors research. So how much human intervention can you have before a vehicle stops being classified or stops being considered as self-driving? We're also looking at it in the context of current definitions and regulation. Something like the AEV Act does set out a definition of self-driving. And we're asking the question as well, as part of all this consideration, how safe does a self-driving vehicle need to be before it's considered safe enough for the purposes of regulation? And that permeates our discussion on the meaning of self-driving, and we dedicate a chapter to it. So that's figuring out what vehicles will count for the purposes of regulation as self-driving. We then also talk about safety pre-deployment in a very large way. We ask a lot of questions about how the regulatory structure should be set up. So asking questions about how much self-certification you might want in an authorization process and how much third-party testing you might want in a regulatory process. We're looking at safety cases because we think they might be quite important, at least in the initial stages of ADS development. There'll be a lot of developers that are developing very unique systems potentially, and therefore we think the safety case will be very important to the regulator. So we look at safety cases in relation to AVs and also how they've been used in other safety critical industries like nuclear, like aviation, like rail. And then we also look importantly at how the initial approval scheme might be constituted. So how you might prohibit the unauthorized use of ADSs, how developers might get a choice, or how you would ensure that developers get a choice between an international route, say through the UN ECE, or potentially a national route. Perhaps they only want approval for their system in Britain, and how you would give developers that kind of choice. And we look at how you would make categorization decisions about what is an automated vehicle and what is not an automated vehicle. From there, we move on to safety and use because we think safety and use will be very, very important for automated vehicles. It'd be important to know that they do perform as you intend them to perform and as the approval body expects them to perform. Or if they don't, that you can learn about how they're actually performing once they're on the roads. So we're looking at a statutory scheme to assure safety and use, to do things like market surveillance. And there's a lot of aspects to that. So there's things like software updates. How do you regulate those? Cybersecurity, which is not in our remit, but we do talk about it in the context of a market surveillance program. Updating maps, communication information to users, and how you collect data. How would that statutory scheme collect data so that it could be fed back into the assurance process? Now, there are challenges with an in-use safety scheme, and we also talk about those in the paper. Breaches of traffic rules by AVs will probably represent quite a dramatic shift. At the moment, what happens is that we tend to prosecute the driver for things that go wrong on the road. That's a very important central point of road regulation at the moment. You have a driver to prosecute. When the driver or the user in charge, as we call them, and I'll talk about that in a second, when when you only have a user in charge or someone who definitely is not a driver, you're not going to be able to do that. It'd be very, very unfair if you did prosecute a passenger for something that the ADS did in relation to the dynamic driving task. So this will be a shift, and what we look at is looking at regulatory sanctions that might be applied by the in-use safety assurance system. So things like fines or withdrawal notices or recalls. Those are the types of things that probably need to be thought about as part of an in-use safety assurance scheme. And we look at that in the paper. We also consider what sort of information you might want from collisions. The UK at the moment doesn't have a specialist investigation branch for road traffic accidents. It does for aviation and for maritime incidents and for rail, but not for road safety, road accidents. Other countries do, some other countries do, but we don't. So we're asking the question whether or not an in-use safety scheme would need some kind of specialist investigation unit like a road accident investigation branch, but perhaps not necessarily going out onto the road investigating, although we are open about that in the paper. But basically a specialist branch that can analyze the data from incidents involving automated vehicles. So safety assurance is a major part of this paper. We are also, though, revisiting concepts which we came up with in our first two consultation papers. So the user in charge in particular is something we revisit in a big way, because we're now trying to put it in the context of the potential regulatory framework. So how does this fit in with the safety assurance scheme and how you regulate vehicles once they're on the road? So the user in charge, for those of you who haven't heard of the concept before, is essentially a human in or in line of sight of the vehicle with access to the controls. And they must be qualified and fit to drive. And that's because they're expected to, following a transition demand, to take over from the vehicle. Or if a vehicle exits its operational design domain, the user in charge might be expected then to get the vehicle off the road or take it somewhere so that it's not in the way. So essentially all AVs should have one unless authorized to operate without one. And there are special vehicles that will be authorized to operate without one. But the user in charge is not responsible for the dynamic control while the ADS is engaged. So for a traffic offense that the ADS commits, it crosses into lanes that it shouldn't cross into, the user in charge is not responsible for that. As long as the ADS is engaged and properly engaged, the user in charge is not responsible for any of the dynamic control or any offenses that arise out of the dynamic control. But they are responsible for other things. So things like insurance, reporting accidents after an incident, and things like buckling up children, which drivers currently have responsibility for. Now, when we consulted on it 2 years ago, most consultees agreed. They thought it was a very good idea to have a user in charge. So in this paper, what we've done is we've developed and fleshed out the regulatory structure around the user in charge. So as an example, we think about the criminal offenses that you might want to apply to a user in charge. There might be things like being in a AV that's, going about its business without a user in charge. So being carried without one, causing or permitting the use of a vehicle by an unfit user in charge, offenses that occur following failed transition demands, but not arising from the dynamic driving task. So the user in charge might be responsible for things like if the vehicle comes to a stop on a motorway, they've failed to respond to the transition demand, and obviously you're not allowed to park on a motorway. They might then be responsible for the offenses that occur at that point. So that's the user in charge. We also revisit no user in charge vehicles. As I said, some vehicles will be authorized to travel without a user in charge. And these are things like, potentially automated buses, pods, things that you're familiar with. many people are trying to come up with use cases where they can pick up passengers, and there doesn't need to be someone like a safety driver or a user in charge in the vehicle. And we concentrated on those in our second consultation paper. So we revisit them here again. What we focus on in this paper are the responsibilities of operators. So responsibilities like the duty to adequately supervise these vehicles once they're out on the road. And there are challenges with adequate supervision, and we talk about those. These are things like connectivity, cybersecurity, training and rest for your remote supervisors, and also failure protocols. What do you need to put in place to ensure that if one of these vehicles stops in the middle of a road somewhere or has an accident, that it's adequately taken care of. We also flesh out what we're calling tier 1 and tier 2 duties. Some no user in charge vehicles, or NUICs as we call them, will be carrying passengers. And so you'd want to place a lot of duties on an operator, or you want to place relevant duties on an operator of those vehicles. Tier 1 duties is what we're classifying those types of duties as. So, for example, you would have the duty to safeguard passengers. That would be a tier 1 duty. And these are differentiated from tier 2 duties. So if you have an automated snowplow in the middle of nowhere, obviously safeguarding passengers is not particularly relevant to those types of automated vehicles. And so an operator of the automated snowplow might only have tier 2 duties. They might have to ensure that it's safe and doesn't collide with anything, but they wouldn't have tier 1 duties like safeguarding passengers. Another important concept which we return to in this paper is that of the ADSE. In our first consultation, we proposed that every automated driving system should be backed by an entity, or an ADSE, automated driving system entity. The ADSE would likely be self-selected. It would put forward the system for authorization. We think that it'd probably be a manufacturer or developer, but it could be a partnership between the two. We don't limit it. And most consultees agreed with the concept of an ADSE. Developing it in this paper, what we've thought about is the potential liabilities of an ADSE. So looking at potential offenses, knowingly or recklessly, failing to provide the relevant safety information to the regulator. Along with that, we're thinking about potential defenses like due diligence, but we're also focusing on regulatory sanctions, moving away from criminal liability and thinking about how you might better regulate an ADSE with things like, recalls, improvement notices, fines, and so forth. So very much development on ideas which we thought about in our first 2 consultation papers and are now putting into place in a potential regulatory system. As I said, we hope to bring this paper out in December 2020, and I think it's extremely relevant for most of this audience. So I hope that when it does come out, that most of you would provide us with your thoughts and reply to the consultation. Thanks.
Great, thanks very much, Connor. Yeah, as you say, this is extremely relevant to CertiCAV. Okay, so now I'd like to move on to our first panel session, and this will be chaired by Richard Holland, who's the team leader for safety regulation and V&V activities here at the Catapult. Richard.
Great, thank you, Zane. Yes, and welcome again, everyone. So yes, as Zane says, I'm team leader, regulation, safety and V&V, reporting to the Director of New Mobility Technologies here at the Catapult. So yeah, just by way of quick introduction, first panel session we're going to have this afternoon or this morning is on the system definition and assurance requirements. I'll take as many questions as come in from the audience as we can, so in the time that we've got, but perhaps we won't be able to answer them all live today. If that's the case, we'll endeavour to publish answers to any questions that we can't answer today after the event. And what I'll do is I'll just now quickly ask each person to introduce themselves on the panel. Appreciate that a number of these are presented today, and have already introduced yourselves, but I'm also aware that participants may have joined the webinar in the meantime, so it's probably worth just doing that again. So maybe Tom, if you could very quickly introduce yourself, just a few words, and then we'll move on.
Yes, so Tom Webster. I've been working at Connected Places Catapult since February this year. So mostly working in lockdown, and been doing quite a bit of work on the CertiCAV project.
Okay, thanks. Just a quick reminder, actually, sorry, please could all the panelists for panel 1 cameras and mics on, cameras on anyway, and mics on when you're talking, please, thanks. So next, Mike Brasher.
Hi, yeah, thank you, Richard. Yeah, so Mike Brasher, I head up the Innovative Mobility team within International Vehicle Standards at the Department for Transport. Thank you.
Thanks, Mike. And Graham, good morning.
Good morning, everybody. Graham O'Brien, DVSA Assistant Chief Driving Examiner. Part of my role would be ensuring the driving test reflects real-life driving, whilst our publications and education pieces are up to date to inform drivers with what they need to stay safe on our roads.
Thank you. And we're joined by Eric as well from Wave. Hi, Eric.
Hey, good morning, everyone. So my name is Eric Barbier. I am the safety lead at Wave, and my primary activity is really to develop a safety case framework for the organization I'm working for.
Thanks, Eric. And we're also joined by Siddhartha. Siddhartha will be talking later, and the more perceptive of you may have realised we've had a little bit of a swap around in the panel. So Siddhartha is now joining us this morning on panel 1.
Thanks, Richard. Good morning, everybody. I'm Siddhartha Kastki, Head of Verification Validation at WMG at University of Warwick, and quite heavily involved with the standardization work and working with the Connected Places Catapult team on the CertiCAV project.
Great, thanks. I don't know, we've literally just heard from you, Connor, so I suspect no one's joined in the meantime, but just very quickly, just again, in case.
I'm Connor Champ. I'm a lawyer at the Law Commission of England and Wales, and we're working on the regulatory framework for automated vehicles.
Okay, thanks very much. All right, so thanks again to all the presenters in the last session. So one of the comments that came up actually in the Q&A, which actually Eric answered, I saw, was sort of with regards to sort of the end-to-end learning approach, and is that actually much harder than doing it in separate stages? So I think really the first question that I'd like to ask, and probably let's ask it to Eric first then in this case, should the separate performance requirements be set for the perception and tactical decision-making components of the ADS? So this was a topic in Tom's presentation. What do you think about that, Eric?
Yeah, absolutely. And that was what I wanted to highlight in my answer. I think we need to differentiate the different stages between perception, tactical decision, and I would also include control, really the 3 main stages. And the reason for that, there are multiple purposes. One purpose is when we're going to try to demonstrate the compliance of that system to a certain regulation, or simply to build up our confidence in how the system works. There are some challenges in the perception that are going to be different from the challenges in tactical decision. So being able to somehow separate that whole pipeline into small chunks is going to allow us to better validate those different modules, those different steps. And also, I would say for nothing else, like an organization like us, if we want to faster develop our system, by I would say dividing that whole pipeline in smaller areas where we're able to put out information that's going to tell us what is working or not working, that's going to speed up effectively our development. We're going to be able to pinpoint more precisely why at the vehicle level the system didn't achieve the performance we were looking for. Is it because of a perception issue, didn't perceive the object, misclassify the object? Is it because the tactical decision was not the right one? Or is it maybe simply because of the controls, we have some latency in the control system, and therefore even if the intent of the ADS system was right, the execution was wrong. So I do, and that was about the aspect of my answer, that even if at Wave we are promoting an end-to-end machine learning approach, that does not mean we have only one neural network. We have a multiple, I would say, level of neural networks, and we believe we have the opportunity to pull out information from those different levels that somehow mimics what other organizations are doing by having a more segmented, I would say, pipeline.
Okay, Thank you. So next, maybe Mike, can I get your thoughts?
Yeah,
on this
thank
one?
you, Richard. Yeah, I think Eric answered it quite nicely, actually. But for me, I think there are two related questions, actually. I think the first one is, what caused the system to behave as it did? Was it the correct decision made for the right reasons or for the wrong reasons? So I think what's important for assessing safety is understanding why a particular behaviour has been demonstrated by an automated driving system. And to understand the reasoning implies a sort of a clear delineation between perception and decision making. I think the second question is then specifically with regards to setting separate requirements is, to what degree can decision making compensate for poor perception? I think if the degree of compensation is limited, then it would suggest that separate performance measures are required for perception to ensure that the decision making is based upon an accurate view of the world around it.
Okay, great. Thank you, Mike. Let's say Siddhartha, maybe what are your thoughts on this?
Okay, thanks. I completely agree with what Eric and Mike have said, but just coming from a verification and validation perspective to this, I think it's important to understand that if you've got separate perception requirements and some separate tactical requirements, then they also need to be tested in some platform or the other. Now, if you start thinking around simulation being playing a key role, but our simulation platforms are not that advanced to be able to test very high fidelity perception requirements. So it's all about understanding what we are trying to achieve in the whole VN system development lifecycle. So if you say we've got very, very stringent perception requirements, can we actually test them? Does that mean that everything would be on real world testing because simulation is not good enough? So I think a trade-off needs to be done over here. And I think more research needs to happen from the VNV side to also inform what kind of requirements need to be there, and also appreciate which requirements is tested at which level of the VNV, sometimes simulation, sometimes real world, or sometimes Hill. I think so we need to take a holistic approach and not just think about requirements in isolation over here.
Okay, thanks. I guess finally on this question, Tom, as it came up in your presentation, anything you'd want to add or elaborate?
I guess that the thing that's always the challenge for us is determining what is a tangible option versus what is not. So, for example, if you were to say, right, I want to get a running commentary from the vehicle similar to like in an advanced driving test of what the perception system understands of the scene, you would be able to determine a lot in terms of not just that the behavior of the vehicle is correct, but that the understanding behind is resilient. But there are obvious issues with that kind of approach in terms of that starting to show quite a lot of how they've actually put that system together. So there are genuine IP concerns. So it's something that's a bit of a challenge, is kind of what is a tangible option versus not. And that's kind of something we have to address a little bit.
Okay, thank you. So before we get to the next question, I'll give, I guess, anyone in the panel that's I've not gone to yet that would like to add any final remarks on this first question.
I suppose I see this question as an output of the system. What's the system, the requirements of the system against, let's say, a competent driver? You know, if you were looking at this needs to be a minimum of a competent driver, but can there be any, caveats to that in terms of the system? I think in some cases there can be. You look at the systems we've currently got, adaptive cruise control. If you look at adaptive cruise control, for example, against what a competent driver can do, this system is capable of doing more. If you look at the 2-second rule, for example, adaptive cruise control can actually encroach on that and arguably be in a safer position. So in terms of requirements, a competent driver would always be a benchmark, but then in certain scenarios, systems are able to actually go that little bit further. And I guess that's where, different requirement settings can be.
Great, thank you, Graham. So next question, sort of interesting one is, let's imagine if a CAV takes a decision to drive on the hard shoulder of a motorway in the UK, certainly, to avoid what it perceives as a serious collision, that is allowed under the provision of what we call Rule 264 in the Highway Code in the UK. So how would you determine perhaps that if there would actually have been a collision otherwise, and therefore if that decision to use a hard shoulder was the right one or not? I think if I can go to Mike first at DFT.
Yeah, thank you, Richard. This question reminds me a bit of the Molly problem that some of you might be familiar with, that Bryn Balcom and the focus group at the ITU have been considering. And it's really, how do you, after an event, determine whether an action was appropriate or not, and the reasons that led to the action. Obviously, if you have someone in the vehicle, you have an eyewitness, or people outside of the vehicle, you have eyewitnesses, and that can provide information. But so the problem really becomes complex when there are no necessarily any eyewitnesses. So perhaps if it was a cargo vehicle, for example. And then I think the question becomes, what's our expectation in terms of the data or the information that the vehicle should be recording, or perhaps even making available to be able to reconstruct a situation after it's happened. That certainly it takes on more relevance, I think, for sort of in-use monitoring. That will play an important role for ensuring safety, for sure.
Right. Thanks, Mike. Graham, maybe can I go to you next on this one?
Yeah, I guess I tend to agree with Mike there. I'd be surprised if it wasn't almost regulated, that there would need to be some form of external monitoring as much as internal as well, once we get to this level of autonomy, with this decision making and trusting the systems in terms of the safety procedures that have been done before that, the testing and so on and so forth. But if that was the case, if there was witnesses around, but I would like to think a monitoring system would almost be regulated before we got to that stage, to be honest.
Okay, thank you. And Eric, your thoughts?
Yeah, actually, I think we're already on that direction. When I look at RSS or SFF that Connor was mentioning in his presentation, for me, this is exactly that. My view is that if we look at an accident today, each driver involved in that accident are going to explain to themselves how they perceive the situation and what decision they made based on that perception. Now we are taking the driver, a system like RSS, who is defining risk calculation, anticipation of imminent collision, should help effectively the ADAS manufacturer to record why some decision has been triggered. And RSA that is in the process of becoming a standard is telling me that I think we are getting to a common consensus with the industry that that's going to be something mandatory that should help fitting into that argument. Now, I think where RSS is falling short at the moment is that RSS is defining what are the conditions that are going to tell us that there is an imminent condition. RSS is not expanding in more details or what is the appropriate reaction. And my view is that very likely we're going to have to identify classes of scenarios, and maybe hopefully as an industry being able to say, if you are in that class of scenario and your RSS system or similar RSS system is telling you that you need to take an action, this is, as an industry, what we think is the most appropriate maneuver that your system should take. And I think if we take that approach, that's going to start harmonizing how we think those different vehicles should be on the road. But maybe Connor has some views on that.
Great, yeah, thanks. Yeah, Connor, let's go to you next, if we may, please.
Can I give a really annoying lawyer answer to this question? One of the things about the Highway Code is it's not law. It's based on law. And 264, I think we looked at it for when we were investigating ALKs. Basically, it says you're not supposed to use a hard shoulder unless there's an emergency. But if you actually take a look at the motorway regulations, what they specify is that you shouldn't drive on a hard shoulder, subject to the provisions of Regulation 7, at least in England and Wales. And bear with me, I'm getting to the point. Regulation 7 says you shouldn't stop on a motorway. So, but if you do come to a stop because of accident, emergency, illness, helping someone on the road, getting something off the road, then you should, as soon as possible, get onto a hard shoulder and stay there for as long as you need, or only as long as you need to take care of things. So, and then move off. So I guess the first thing here is figure out whether or not, at least in England and Wales, because of course there's Scottish transport law as well, and it's similar, but it's worded differently. The first thing to figure out is, would the vehicle have stopped because of an emergency on the road? So that's the first thing you'd have to figure out if you were thinking about, how to apply 264 to an automated vehicle. I think in practice, if a vehicle thought that there was going to be an emergency and came to a stop and then pulled over to the side for just as long as necessary to make sure that it wasn't going to crash into something, I think it's very unlikely that the vehicle would be charged, but it would be done on a case-by-case basis, I think.
Great. Thank you. So I would like to, I'm aware of the time, conscious of the time, I want to make sure we give you all a break as promised. But just want to try and take a couple from the audience, if I may. The first one actually came in during Tom's presentation. So maybe Tom, if you could take this one briefly. It says, given the timelines depicted, could you outline the responsibilities of some of the key stakeholders that were mentioned?
Well, I think the responsibility. I think the best answer I can give to that is what we've done that I did not present is we've done a structure chart of what the relationship between all those stakeholders is, which we actually based on the largely a lot of that data came from the Law Commission report number 2, actually. We thought that was quite good terminology in general that we aligned with, although I think we might need to review it a bit when the third one comes out. And then we've then actually had to go in terms of looking at the deployment, what the tasks are and what an actual RACIC roles and responsibilities are. So I think we are intending on actually clarifying what those roles and responsibilities are. We're focusing on the kind of the threesome of the kind of like the vehicle regulator, the ADSE, the system developer, and the whoever's kind of doing this independent testing. But then some of those kind of ones slightly outside may feature in terms of what they do. So I think they're kind of their roles and responsibilities are kind of common sense in a sense, but we are making sure we kind of think about it and do our best to take care of what they're doing.
Okay. Thank you. I'm aware of the time, so if I may, just one final one. It's actually been directed to Connor. Are the Law Commission only looking at the use of vehicles in public spaces, or also for workplace automation? So, for example, warehouses and airports.
Just roads and public places.
Okay.
Basically, that's our remit. I think some of the things we talk about in relation to what we're calling NUICs, no user in charge vehicles, might have applications, and we've certainly talked with a number of groups that are interested in automating workshops, but no, the remit of our work is strictly roads and public places.
Okay. Well, great. Thank you all very much. Been really informative and interesting panel session. We are at 11 o'clock here in the UK now, or just after. I believe we've promised a 10-minute break. That's correct, Zane. So, yeah, please feel free to take a short break, and we'll resume with the next presentation from Rob in 10 minutes. So that's 10 past 11 here in the UK. Thank you all very much, and we'll speak to you again very soon.
Okay, welcome back everybody. I have it exactly 11 on my watch, so let's get started again. I hope you've all managed to get yourselves a nice coffee and ready to carry on the interesting discussions. So now I'd like to hand over to Robert Myers, who's the systems engineer who's leading our work package in charge of creating a software toolkit and demonstrating some of the assessment methods that we're working on. Rob.
Good morning. Yes. So most of the workshop today is about what the certification framework should look like and what it should do. What I'd like to talk about over the next 10 minutes or so is a different but closely related topic, which is about how you might implement some of what we've been talking about. So to start off, the aims and objectives of what we're trying to do, and I should say that what the objective isn't is to produce a production grade software which can be used to go away and certify connected and autonomous vehicles. What we really want to achieve is showing that some of the ideas we've talked about today and we'll be talking about in our publication at the end of the project are that those ideas can actually be made to work and they fit together properly. And with that in mind, there's three things which we want to demonstrate and create. First of these is this idea of a format. So it's often talked about that we're going to be running scenarios in simulation and making decisions on the results of those simulations. But what does the output of a simulator look like? We see a need for some sort of a format, probably aligned with open standards, such as a SAM's open simulation interface, perhaps, which pulls together all of the information you need in a raw data format to make pass-fail decisions. And secondly, we want to create an example of this process for making pass-fail decisions. So I think a key property of this is that it needs to be something which is transparent. And by that I mean someone could come along, look at the raw data results in an interpretable format, look at the processing which has been done, and understand how a decision's been reached. So that's why we sort of see this as a standalone component rather than something which is built into a simulator or another tool. And finally, there's the idea of a demo. So we want to bring this all together, show that all the components we've talked about and thought about fit and interact properly, and also use it as a tool to explain the project to people. There are quite a lot of different ways which certification could work. Tom talked about some of them earlier. For the purposes of demonstration, we're taking one example which we think is plausible. And that's the case where a regulator comes to an ADSE and asks for a particular set of scenarios to be tested and to be shown, not just told, but shown the results and how this demonstrates that the vehicle performs safely in those tasks. I have to stress that this isn't a recommendation or a decision about how the process should work. It's just a plausible concept to illustrate the requirements. But when you get into the detail, I think actually a lot of the lower level requirements will turn out to be the same, regardless if you're talking about something done internally, which is audited, or externally, which is independently carried out. So that's the sort of high-level aims and what we want to demonstrate. I'd like to go through in a little bit more detail what we're actually going to create as part of the CertiCAV project. So I should say, by the way, that the things which pop up in green solid blobs on this slide are things that we're planning to develop to demonstrate, and the other things are items we want to interact with. So our assumption is that this use case I talked about a second ago, where a regulator asks for some scenarios to be tested, that would be provided in the form of a database query for a scenario database. And with that in mind, we're planning to integrate with the music system, which the Catapult has developed as part of the previous project. So the regulator provides a query, and our test manager script uses that to extract the correct scenarios from some sort of scenario database. Secondly, those scenarios need to be executed and this raw data needs to be gathered. Now, actually, this could take quite a few different forms in reality, but the assumption we're using here is that it's done in simulation and that we're going to be using the Kala simulator, which is free open source software, to demonstrate it. That Kala simulator will be used to collect that raw data which we needed and feed that back to the test manager. And finally, there's this scoring and evaluation, which we'd like to create at least a few examples of. And as I said earlier, we see a need for this to be a relatively independent process. I'd like to talk in a minute about a couple of the challenges which scoring and evaluation raises. But first, there's one more point to make, which is that actually this process might not happen within a single organization. So we're designing everything to be split down the middle with this raw data formats in the middle, which kind of creates a bridge between the test execution side of things and the test evaluation. And that's actually relevant whether you want to audit the results or to do a certain part of the evaluation independently. So I've talked about our objectives and I've talked about how we propose to achieve them. One final thing I'd like to mention briefly is a technical challenge around scoring and evaluation. There's quite a lot of good work out there which looks at ways of scoring how good or bad an outcome was. So, for example, there's the Pegasus criticality metric, which tells you how close a vehicle was to crashing or how close a vehicle was to exceeding its dynamic limits. I'd also like to give a quick mention to the CertiCAV passenger comfort metric, which will hopefully be published in the next few months. And that looks in a broad sense at how passengers will feel about riding in the vehicle. Not just in terms of dynamic forces, but also in terms of interaction with other road users and things like driving too close to the vehicle in front. But what these measures don't give you on their own is a sense of what should have happened. They could tell you that a piece of driving would have been extremely uncomfortable and perhaps even scary for the passengers. But what's difficult to determine is whether that was a good outcome for the situation the vehicle was exposed to. And for the purposes of scoring and evaluation, we see there are two general methods for tackling this. The first is easy to measure but hard to define. So for each scenario or situation, we simply say, for each metric, what level of performance is acceptable. So we say our passenger comfort score must be greater or lower than a certain value, depending on how it's defined, or that a certain rule shouldn't be broken. But what this does mean is that it's quite a challenging task to define exactly what the numbers which go in here should be for every scenario. The alternative is to do something more statistical. So looking across a range of scenarios to understand what the general properties of a system are or were. And this actually has the opposite problem. It's relatively easy to come up with definitions to say, passenger comfort should generally be high, road rules should be broken rarely, critical situations shouldn't happen too often. But what's very difficult is to work out how the scenarios which were tested relate to the real world. And the reason this is difficult is because we're not talking about random failures on the whole. In CertiCAV, we're focusing on normative operation, the CAV. So that means that what our scenarios tell us is not how often something will go wrong, it's the situations when something will go wrong. It's not useful to know that there will be one collision per 1,000 scenarios tested. The relevant information is how often that situation will come up in the real world. So it seems to us that to do statistical evaluation in a meaningful way, you need a very detailed knowledge of real road user behavior in the domain where the vehicle will be operating. So what does this mean for the software toolkit? Well, we can certainly demonstrate some examples of thresholds which look like this. That they may not be perfect and they may not be applicable to every situation, but it's relatively straightforward for demonstration purposes to come up with examples for particular scenarios which give sensible results. And we can also build in a capability to make statistical evaluations, so we can implement metrics and produce scores against the metric. But of course, both of these leave an open question, and that's what should these scores be? What should the thresholds be versus exactly how likely is each scenario to come up in real life? And we think that those are questions, very difficult technical questions, which would have to be addressed as part of the project, much broader than CertiCAV. So thank you for your time. This is a little bit different from the other sessions because it's about implementation rather than concepts. And so I'm going to do a self-contained Q&A rather than joining in on one of the panel sessions. So please do put questions and comments in the chat.
Thanks ever so much, Rob. Thank you. Yeah, and so while hopefully a few questions are coming in, we've just got a few minutes for this. I guess a couple to get us started. You mentioned CALA. How closely tied to CALA will the toolkit be? And will it work with other simulators, for example?
Well, how will it work with other simulators? The idea is that it will work with CALA out of the box, if you like. We're aiming to make it as not tied to CALA as is possible, while still fulfilling the aims of the demonstration. So there will be, obviously CALA will be the bit where we're, for example, adapting the simulator so that it can produce data in the format we've come up with. But there's no reason that you couldn't do a very similar process to produce the same format for any other simulator. So really, the concept is generic. Bits of the implementation have to be specific to the simulator for practical reasons, but there's no reason they couldn't be swapped out in the future, and we'll be trying to design as far as possible in a way which allows that.
Okay, thanks, Rob. And one coming from the audience then. So how do you foresee working with third parties to extend scenarios, test cases, and capabilities?
Okay, I think there's two answers for that. So the first answer is the immediate next few months on CertiCAV answer, which is that we're looking to produce a demonstration to prove the concepts. And that means we'll be picking a small number of scenarios. I'm very open to hearing inputs if someone has a particular idea of what they should be or what would be interesting to demonstrate, and implementing them in-house. There's then the longer term answer about what a certification process should look like in terms of where it gets its scenarios from. And I think that's a much broader question with no easy answer. But the short answer is you want to test the system against as many scenarios as possible. We're not building that for demonstration purposes, but that would be a long-term goal.
Okay. Fantastic. All right, thanks very much, Rob. So I think it's probably time to move on. Maybe if there's any other questions that come up on this topic in the meantime, Rob will be online and maybe can answer some of the questions live by text, or else, like I say, we'll endeavour to publish some answers after the event. Okay, thanks very much.
Great. Yes, thanks, Rob and Richard. And could I now introduce Siddhartha Kastegir from the University of Warwick's WMG group, who should be talking about some of his work, which is now part of the CertiCAV efforts on scenario generation.
Thank you, Zane, for the introduction. And I will just try and share my screen. And hopefully you can all see it in presentation mode.
Yes, that's working now.
Perfect. Thank you. Okay, so now that we've got the technical things sorted, so I'm Siddharth Kaski, as Zain said. So I'm from WMG at University of Warwick, leading the verification validation research. And today I'm going to talk a bit about ODDs and scenario generation and the relationship between the two. I think over the last few months, a lot of focus has been put on scenario generation and ODD in isolation. And I would like to bring them together and also take the concept of ODD beyond scenario generation, because there are quite a few other activities that for which ODD is essential. So I'll start off with a brief agenda around the scenario, around the presentation, go into a bit in scenario content generation without the ODD in the perspective, and then take a bit around why ODD is important. And at the end, I'll try and mention a bit about why standards are also important and how these two schools of thought can come together. And then I'll summarize my presentation. So very briefly, scenario content generation can be done in various manners. I think over the last 2 years or so, the industry has come to the consensus that scenario-based testing is the way forward. And within that, scenarios generation is a key aspect of it. We've got a fairly novel approach, which now has become widely accepted, that you can have a knowledge-based approach and you can have a data-based approach to creating scenarios. So on a database approach, we do accident database analysis, we do insurance claim records analysis to identify trends that contribute towards accidents, and then use those parameters as scenario parameters. And the knowledge-based approach, which I'm also going to talk a bit more into detail from an ODD perspective later, is trying to analyze the system itself to understand how the system would fail. So we work with a method called as STPA, which stands for Systems Theoretic Process Analysis, that was invented by MIT, and we extended it for test scenario generation. And all these three methods together will create scenarios, and you will pour it into a scenario database that you might have in your organizations or a regulator might have. But the interesting bit is that these three methods are not the only methods of creating scenarios. So you might have another fourth or fifth or a sixth method, but all these methods together will create scenarios in isolation. Right now, they create scenarios in isolation. And all this work I'm just talking about is part of an OmniCAV project that we've been very fortunate to be part of. But irrespective of how you generate scenarios, all scenarios essentially will have things like a scenery, which is defining the roads, the junctions, the bridges. It will have environment, which is the weather, the time of the day, visibility, etc. It will have dynamic elements like vehicles, pedestrians, traffic. But the interesting bit in a scenario is it will also have the behavior associated with all these kind of elements. It's not just a spot description of the world. And essentially, these three elements is what an operational design domain is, or what an ODD is. So there is, you can see from a structure of a scenario, seems to be a link, but it's not quite there's not a consensus in a way where we say, if this is an ODD, this is a particular scenario. And that's the challenge that we're trying to sort out in the CertiCAV project, and also from the other projects. So very briefly, some of the things that we already know of as to how you use scenarios and ODD. So I won't spend too much time on this one because we already know of this. Suppose you've got a scenario database that has thousands and thousands of scenarios. So one of the easy uses of an ODD is you use the ODD labels like pedestrians, cyclists, passengers. And for example, you want to find all the scenarios that are relevant for a city center. So you'll use those ODD labels as scenario labels and query the database, and you'll get all the scenarios relevant for your particular ODD and for your particular application. That's a very standard way of using ODD and scenarios, but that's not actually using ODD to generate scenarios. That's actually using ODD labels to filter out scenarios, which is a very different thing. So what I want to get across today is, why is ODD important and how do you make and bridge these things together? So we already know that ODD is all about operating conditions. That's a given. We understand that. It's part of the definition of the ODD. That's easy. But the interesting bit here is, which is a less appreciated concept, which I want to focus quite a bit in the latter half of the presentation, is the relationship between ODD and what we call as behavior competency. Now, what essentially behavior competency means is it's the behavior that you're allowed to do on the road for any pedestrian or any a vehicle or any other actor. Now, you can have a behavior library for all these actors, but that library will actually be a function of an ODD. So a classic example of this is, if you follow the rules of road, and I will caveat that, if you follow the rules of road, on a motorway, you do not expect a pedestrian. That does not mean that you will not test for that particular scenario, but from this base scenario perspective, the behavior competency for a pedestrian, if you have got an operating condition of a motorway, you will not have a pedestrian maneuver on that, but then you'll add the noise on top of it, that's separate. Similarly, you could also say, I have an ODD definition on which I do not have an unprotected left turn requirement. So you will not have a behavior competency of unprotected left turn or right turn, depending upon which country you are in, unprotected left or right turn as part of your behavior competency. That's a very important aspect that we tend to lose out when we are generating scenarios. In the search for randomness and randomization and fuzzing, we tend to not do it intelligently. And if you add the layer of ODD and the implications it has on the other aspects of the scenario, that process can become much more efficient. So behavior competency is one aspect that will help us generate the scenarios. And I'll go into details in the next couple of slides. The other one that I want to talk about is safety metrics. Now, there's a lot of talk about how safe is safe enough, and Tom's done a fantastic job of giving some of the concepts over in the earlier presentation. But the concept that we're trying to get across now here is the safety metrics themselves are also a function of ODD. Now, for example, if you got a low speed shuttle, your safety metric would be very different to a ALKS system or a motorway chauffeur system. And that is another technical concept that is not well appreciated and established right now. And thirdly is the concept of completeness. You can talk a lot about coverage, but that coverage needs to be a function of something. And that something has to be the ODD. So these four building blocks are all related to an operational design domain definition. We tend to treat them separately and we don't tend to bring them together. And I think that's where the CertiCAV project will be building on some of the other work that we've done at WMG and with our partners. So how do we bring these things together? The first thing we talk about is ODD and behavior library. And I'll tell you how you join them together. So just to make a brief note, so I've been very fortunate to be working with the World Economic Forum over the last 7-8 months on coming up with a scenario-based AV policy framework, which was just published yesterday. So this piece of discussion that I'm going to have right now with you is actually part of that report also, and that we've discussed with our stakeholders across the world. So the way you go about doing this is you first define the location for where you're going to deploy your system. So you're defining the location. You can use, you can use the ODD taxonomy. You can use any taxonomy, be it the BSI PAS 1883, or you might have any other national standard that within your own country. So you could use your taxonomy to define the location. So you've got a formal definition of your area where you're going to deploy your CAV. Now, you add to that the type of behavior that you want in that location. What happens right now is we tend to treat these two systems, these two stages independently, which is a wrong approach in our thinking. And this is by no means a standard approach, but this is a part of the discussions that we've had up until now. So you add the behavior on top of your ODD definition. So you'll cull out a lot of the behaviors that are not relevant for your particular location. As I said, so you might not need an unprotected right turn, or you might not need a left turn for your particular operating area. So you need to bring those two together. Now you could have a behavior library. A concept of behavior library is again something that hasn't been standardized yet, but there have been some discussions from Waymo in the States and from Singapore and TNO who are creating a concept of a behavior competency or a behavior library. So if you marry the behavior library with the operational design domain definition, then you essentially get a set of what you might want to call as a qualitative scenario, or in the Pegasus terminology, you might even call it as a functional scenario. So if you marry those two together, you will get a set of functional scenarios, and then you can derive the corresponding logical and the concrete scenarios. Now, the scenario library that we've been talking about all this while could have all three types of scenarios. It could have concrete scenarios, it could have logical scenarios, or it even have qualitative scenarios. There's nothing stopping us from storing all types of scenarios within the scenario library. And then the other bits that I mentioned about the relationship with an ODD is the is the metrics and completeness. Now that you know what your behavior is, you know what your ODD is, then you can derive the metrics and completeness accordingly. Now, given that this is the framework in which we want to work with, let's revisit the scenario generation process that I spoke about a bit earlier. So you've got these three different mechanisms of accident databases, insurance claim records, and the STPA-based scenario generation. So we'll revisit one of those methods with this philosophy, and I'll tell you how this philosophy can be superimposed on that same activity. So we'll use one of these methods. In the interest of time, we can't go about explaining all the three methods and superimposing on all of them. So I'll use one of them, which we feel is the most insightful because it can give you multiple pieces of information. So we'll use the STPA-based scenario generation process as an example to overlay the philosophy that I've just mentioned. Now, for those of you who are not very familiar with STPA, I will very briefly mention that STPA is a systems engineering method that for hazard identification that was invented at MIT. And essentially what it does is it considers safety as a control problem. And any accident or any incident is actually due to a breach of a control law. Now, we don't have the time to go into the details of STPA in this presentation, but if you want to have a separate conversation, we can go have a separate conversation. But what I wanted to focus here is STPA itself has got 4 steps. So you'll get step 1, 2, 3, and 4. In the first step, you create a control architecture of the system, and it can be very abstract. It can be very detailed depending upon the level of maturity of the system. But what I wanted to focus here is the extension to STPA that we have provided. Now, with that extension, you can use the 4 steps that you have of STPA and the outputs of those 4 steps, and using those outputs, you can create test scenarios. And when you're doing those test scenarios, we tend to, structure them in the elements of the operational design domain. Now, one of the things I wanted to mention here is, depending upon your system maturity, and especially with these kind of systems, initially you might have very high level system understanding. So you can actually perform an STPA at a very high level. So this control structure that you see right now, the architecture that you see, is more or less a standard architecture for any autonomous control system. You will always have that. But you could also go a bit more into detail and try to understand what are the different types of interactions within the individual boxes. So if you want, you could also go in within global path planning blocks and create the control architecture within that block. This presentation is not about STPA, it's about the scenario generation process. So I'll go into that. So one of the things that we do out of the output of STPA is we overlay the scenario parameters on top of it. So things like scenery, environment, and dynamic elements, we overlay that on top of the output of STPA. So within STPA, we've got a concept of a context within the analysis. And that context is a function of scenery, environment, and dynamic elements. Now, you could say with a brute force approach, you will do and explore every aspect, every attribute. Now, that is an approach that you could do, but it's not a very intelligent or a very efficient approach. If I say I could use the ODD taxonomy to inform my test scenario structure or the test scenario selection, then it culls a lot of those irrelevant parameters and makes the process more efficient. Similarly, when I'm exploring the dynamic elements and I've got these behaviors, the maneuvers that you see over here are akin to the behaviors in the behavior competency. So if I have selected only 4 behaviors out of 100 behaviors in my behavior library, then my test scenario generation becomes much more efficient. So I don't need to have those combinations for all the 100 behaviors that I have in my library. So that's again another way of making that process efficient. So the other bit we also wanted to focus is, if you talk about this process of scenario generation in the wider safety assurance process, that's again a big plus that comes if you follow from this process of STPA. One of the reasons for this is it is very powerful in actually uncovering the unknown unknowns. People can debate what's an unknown and unknown, but there are many evidences that are given out there that prove that. A most recent one, so if you look at the Waymo safety report, and I've just put an excerpt from the Waymo safety report, and it says that STPA can mitigate hazards that may arise from non-obvious component interactions and may be better able to than more traditional hazard analysis methods. So there is another opportunity of integrating STPA within the wider safety assurance process. So now what we started with was an ODD and scenario generation. We said, oh, we'll do STPA-based scenario generation, but then you can also branch out into STPA within the wider safety assurance process. That's the whole idea of this project, is to bring things together. And we are highlighting individual aspects of the safety assurance process, but at the end of the day, we'll all bring it together. And that's essentially what I want to get finish off with. So any testing evaluation continuum or any VNV process will always have these 3 categories, these 3 elements. So you will need scenarios, you'll need a test environment, and you'll need to understand how you will how you'll argue with the safety evidence that you've got. So irrespective of if you're doing digital world simulation, or if you're doing hill simulation or test track testing or real world testing, you will always have these 3 things. But if you take it a step down, if you talk about scenarios, you'll always need to create scenarios, format those scenarios, store those scenarios, and then you'll need to plan and execute them in an environment. And at the end of the day, you will need to analyze and decide what the output of that testing regime is. Is it a safe product or is it not safe product? Is it a pass or is it a fail? So essentially, that's what you're doing. Now, if you come with the concept of an operational design domain and overlay on this aspect, so on the create aspect, I've already gone through into quite a bit of detail as to how the ODD will help you create your scenarios with the behavior competency overlaid on the ODD definition using a taxonomy. Now, a format is more for enabling interchangeability and interoperability. So that's a given. From a storage perspective, if you've got a scenario library, we've also mentioned about using ODD as a search criteria. So that's more for efficiency of test planning. Now, this is an interesting when it comes to test environment. So if you've got a fairly simple operational design domain, and nothing is simple, I know, but it's relatively simple. I shouldn't use fairly, I should use relatively. So if you've got a relatively simple operational design domain, then it's very easy to understand if you actually need simulation or you can do a lot in real world testing. And I see Zain here, so that means I need to finish up quickly. So thank you, Zain. So that's my penultimate slide. So that's what I wanted to also mention here is aligning with standards is important, but not always possible. because it's a crowded landscape. There's lots of organizations out there like ISO, BSI, ASAM, SAE, who are developing standards. So what we need to ensure is, as a community over here, that we develop complementary standards and not competing standards within different countries and within different organizations. So in summary, what I'd like to say here is scenario-based testing is a given. The industry has accepted it. That's a good thing, because I think that's the way forward. But the bit that we have still not grabbed that much is the ability of an ODD be informing the scenarios, but also informing the behavior competencies and the metrics and the testing completeness decision. I think that's the leap that we're going to make through the CertiCAV project. And essentially, every system or system of system needs to consider the relationship with an ODD. And at the end of the day, I would like to say, if we are going to be successful in the CAV arena, it's only possible if we collaborate and share knowledge between us. So a collaboration, both nationally and internationally, is key. And that's all from my side. Thank you. I'm not sure if I ran over slightly.
Right. No, thanks very much, Siddhartha. Okay, now we go back to Tom Webster. After he's spoken about the requirements for the process earlier this morning, now we want to talk about how you actually execute the assurance process. Tom.
Yep, I'm just clicking all the buttons I need to click. Apologies. Yes, so okay, so now I'm talking about the assurance process, kind of the goals and relationships. So I don't want to get too distracted with standards, but I'm mentioning standards because they're key to the relationship between the system developer and an independent insurer, because they in effect interact via common practice. So if standards and so on and so forth are sufficiently well developed, then this allows testing and certification activities to be well integrated with development activities, and it allows certification activities to take place and that kind of thing, which provides assurance. Currently, there's lots of gaps, of course, for HAV, and there is lots of active development which is starting to fill that gaps, but there's lots of parallel activities, and so to an extent we are guesstimating the way things are going to shape up. This is another one of my kind of things showing practice processes, and there's a few standards, and that's just a small snapshot of what there is out there feeding into all these different processes in various stages of development. And then the system developer and independent insurer are kind of interacting with those. So part of our work is looking at how we might contribute, identify a few things. So there are a few key development areas that are particularly important to our scope of safety assurance. So data formats, so relating to what Rob was talking to earlier, in a large extent, that to support the interface for testing rigs, and you need things like ASAM, OSI, and for exchange of data in order to do evidence evaluations, and also for monitoring. So safety of intended functionality, as it stands, it's only the only normative content of SOTIF is covering objectives. So it first of all needs its normative scope to be expanded into the methodologies and practice, but also it does require extension to cover higher automation levels, and kind of relating to what I was saying earlier in terms of this thing with behavioral safety. So the practice is required for how do you actually go about developing an intended functionality when it's not specified in an individual standard for a driving function, and how do you verify and validate it, and how do you make sure that it's fully responsible for the dynamic driving task. So it's very different when you can no longer have false negatives, false positives, because there isn't another kind of agent in the car, i.e. the human, who can take some responsibility. So you need fully automated fallback, and no kind of outlying false negatives that can't be covered by fallback. Yeah. So then we get into the road traffic regulations highway code. So the current system of road traffic regulation, it's not validated for application to automated vehicles. It's kind of validated by history, that it works for humans. We know its safety record for humans, but it's something that's evolved over time as something which, when presented to humans, works for them. And we don't actually, it's not actually validated how it relates to automated systems. You can't technically verify system performance against the existing fabric because there's lots of subjectivity to how it's defined. So anything that can be done in codifying the highway code will help. So although it's impractical, we completely accept it's completely impractical to make all of it fully explicit. Any work that you can do to organize or interpret the contents will provide some valuable resource to help developers and to help assessors. And then there's the probabilistic systems and machine learning. So things like, I mean, is online learning even permissible for certain use cases? Cooperative safety. So the general standards for CITS are quite well established, but they have not extended to the use case of providing safety critical support to highly autonomous vehicles. So it's generally accepted that digital infrastructure support is required, that but it's not been worked out, the standards aren't there in terms of how it's actually going to work. And care will need to be taken to make sure that digital infrastructure is implemented in a safe way. So if you're using it as a parity check against onboard sensors, that makes sense to me. If you're like relying on something that's digitally communicated for safety, and if that's corrupted, you had a dangerous outcome, then that can cause problems. Change management is another area that needs to be managed. So over-the-air software updates, software will need to be updated, and there needs to be a management system in place to manage that. So when it comes to how things relate to a system developer, it's not very exciting. Effectively, there's requirements, and the system developer, well, they need to take care of the requirements. There's a little bit of nuancing in the objectives that need to be covered. So So in relation to what was presented earlier, a developer will need to sufficiently coordinate and explain what they're doing. And also something that starts coming in, and a lot of this is relating to what Siddhartha was saying earlier, that there's this need to have a cohesive, integral safety case where everything is managed in one cohesive safety case that organizes everything together. This is part of the quality management. It's not just about presenting the safety case in a way that other people understand what's going on, but it's about coordinating all the different validation activities together. So testing culture. So there's just some general principles that need to be applied. So making sure that validation's managed appropriately, that things are monitored, and that when there is testing on road, that is then leading to actually upping the validation. So one other thing that comes in is this. So the behavioral safety case. So there's a relationship between how the system is defined and what the intended functionality is, and how you can then argue the whole path through to the performance requirements. So if the deployment is constrained in such a way that you can argue that safety is maintained based on some quite prescriptive, relatively prescriptive intended functionality, and that maintains safety, then that has a big impact on how the whole safety argument fits together. So then when it comes to independent assurance, so what an actual kind of licensing activity takes place. So, I mean, of course, I don't want to repeat too many things. I think there's a general would suggest that there's a general expectation that if you are coming and saying, I am ready to truly operate driverless, that you can show that you have deployed, that you've got the maturity, that you've deployed in that area with no interventions. If you can't operate for a significant period of time, you haven't got the validation, you're not mature. So that is a significant part of evidence that's brought in. And then as well as the other key objective to kind of doing all the audit and assessment is then doing some independent selective testing to really do that double check that the system is safe. For when you're doing this fully independent system, for it to have full access and repeat all evaluation activities. So one way of potentially managing this is to have a deployment risk classification. So based on hazard severity, deployment scale, and behavior complexity, you can have a deployment risk class, and that can be used to scale the coverage. So it's not changing what the requirements are or the acceptance criteria, but it could scale what is the coverage of the independent assurance. And there's an example there. So this is taking the ASIL levels, this is recycling the hazard severity levels from ASIL and then applying that to kind of notional deployment risk are. So what this then looks like in terms of process, deployment check, the objective is to check deployment specification, a road test. It could be at the end or it could be at the beginning, and there's two objectives you're covering there. You're assessing the deployment management. Can it be demonstrated that that deployment specification actually works in real life? And then you're assessing the competency of how the vehicle drives on the road, kind of like a driving test or the inspection. Safety case evaluation, then generating test cases, aiming to create effective tests to get independent assurance that the system's safe. You've got kind of physical testing, test bench testing, and then you want to cross-reference some of those to make sure that the test benches are correct. I think this is largely a repeat, and Siddhartha covered quite a few of these points. Just to note quickly that an advantage of that, having that explainability and that access to the system. So if we go, we're going back here to that slightly broken down ADS I had earlier. Then you can then structure, you can actually layer scenarios, break down the tests. So this is somewhat notional, but if you're looking that you can break down the parameters of an overall complete space of scenarios. If you can test and characterize each of those subsystems and get assurance individually, the number of tests you're doing is vastly reduced. So people can be presented with an option that if you've developed the system in such a way that it is more explainable and that you're able to provide access for the independent testing, then you have much less effort that you need to go through for that independent assurance. And then this is somewhat similar again to what Siddhartha presented, but just to say that yes, you can. The general idea is you generate scenarios that provide a good challenge based on what you know from the deployment specification and what you've learned from audit, and that this is somewhat of what a system looks like. So there is sense in having a common scenario management system, which is both a tool for generating those tests, but also helps link everything in with the wider knowledge and management of things in the long term, in terms of you've kind of got that list of functional scenarios and parameters, and then from your monitoring data, you've got, it's helping to fill in that constant feedback cycle and making sure that assurance is already kind of following a kind of excellent process. And then that's just a bit more on testing, but I think I've run out of time again, so I think I'll skip over that one. Have I run out of time?
Yeah, I think so. Really, I think we should move on to the final panel session. So I'll hand back to Richard, who's going to be chairing this panel.
Yeah, thanks, Zane, and thanks, Tom. Yeah, so welcome to the second panel session this afternoon. I'm really pleased to be joined by representatives from Hariba Myra, TRL, VCA, and 5 for this session. So as before, I'll let the panel members introduce themselves, say a few words about yourself and your role, and then we'll move on to the questions. So, so we've heard from Zane, but very quickly, Zane, just in case I don't think it's the case, but in case anyone's joined very recently, just say a couple of words about yourself, please.
Yeah, I'm a principal technologist at the Catapult. I work on safety assurance in V&V for autonomous vehicles, and my background before that is mainly in AI and robotics research.
Thank you. And Tim Edwards, afternoon.
Hi, thanks, Richard. Hi, everyone. So I'm Tim Edwards, Chief Engineer for CAV Technologies at HAV Myra. And also kind of relevant to this is I'm overall project technical lead for the VeriCAV project.
Thanks, Tim. And hi, Camilla.
Hi, yeah, it's Camilla Fowler. So I'm head of automated transport at TRL. My background's very much in risk management and safety case development, and I'm the author of PAS 1881 that looks at safety case requirements for operational safety cases for CAV trials and testing.
Brilliant, thank you, Camilla. And Matt from VCA, hi.
Afternoon, everyone. Yeah, I'm Matt Clayton from VCA. I lead the Automated Vehicle Technologies group at VCA. Background for many years was a type-proven engineer on the operational side of testing and approving vehicles, and now responsible for the policies and technical interpretations around automated vehicles and associated tech.
Great, thank you. And finally, Ian, good afternoon.
Last and least. Hi, I'm Ian Whiteside. I work for FIVE. I lead our assurance efforts there. Yeah, my background is in V&V, both in academia and NASA on aerospace. Yeah, good to be here.
Great, thank you. So yeah, just a reminder, this second session topic is assurance process goals and relationships. And I say as before, we'll endeavour to get through all the questions that we can, and any that remain, we will try to post written answers after the event. So I suppose the first question, there's been a lot of talk around the scenarios, scenario databases and creation in the presentations. First question really is do we think there should be a standard set of regulatory scenarios that developers, or rather ADSs, are assessed against, in addition to the developer's own scenarios? So maybe Matt, if I could start with you on this one, please.
Thanks, Richard. Yeah, I mean, Rob put up a slide earlier with a picture of somebody who may well be me or one of my colleagues in the future, asking a manufacturer to demonstrate a subset of their scenarios as part of an audit. And yeah, for sure, we need some tool or some methodology to choose which challenging scenarios we're going to ask the manufacturer for. And I think that the complexities of the systems and all the permutations that they might have and all the different ODDs, we need some kind of tool or database to help us with that. I think the flip side is that if you have an open public list of regulatory scenarios, then it's not really proving very much when we find that the vehicles perform well in those scenarios. So I don't really have an answer, but perhaps it's either the regulatory database has to be not the same database that the manufacturer uses, or that perhaps the regulatory database would be much more higher level, sort of qualitative scenarios, and then the conversion of those into logical and concrete scenarios is sort of done by us on a case-by-case basis, so that we're asking kind of surprise or challenging questions at the point of audit.
Okay, thanks. Okay, so Ian, let's say, what are your thoughts on this?
Yeah, quite a few different thoughts. So, like, first of all, it certainly won't hurt. And then, like, second of all, I think it's sort of useful to make this distinction between, scenarios that you might actually run on a test track and scenarios that, like, you're going to run in simulation. And, like, this type of thing is probably easier to do on a test track, but harder at the same time. So what do I mean? Like, it's easier in the sense that a body can administer and do it consistently over time, and we have a little bit of experience about that, and like the UNECE ALK specification is reasonably good to enable type approval body to go and choose a sort of concrete instance of one of those scenarios and run it on a track. Of course, it's much harder because it doesn't test much diversity. You need the weather to be playing ball to get comparable conditions, and you need to validate that the tests are actually not sort of like introducing some residual risk compared to driving in the real world. And so one sort of thinks, oh, okay, well, going to simulation is a good thing here, because we can do many more tests across a much more diverse like landscape, many different maps, and we can do much more dangerous tests and high-speed tests, etc., etc. But of course, you get the problem, which I'm very well aware of because I'm leading the Open Scenario 2.0 semantics working group, where actually if you formalize a scenario in a formal script or something, like every simulator is going to execute that in a very slightly different way. And you have to be very, very careful here, even if you solve the problem of having one language that everybody is comfortable using to specify these things. Actual implementations are going to vary. And it's still a good thing to understand these scenarios, but anybody auditing or using them as part of like an assessment for giving a license has to be very clear about the drawbacks and limitations of using this, and needs to sort of reduce the residual risk in other ways.
Okay, thanks, Ian. And maybe if we go to Camilla next, please. What are your thoughts on standard scenarios?
I think the key thing is consistency. You can have such variability in even with a sort of central database of scenarios, you can have real variability between organizations and how they apply them. And your simulation is only, your output's only as good as your input. So I think it's about having that sort of consistency in the way that the automated vehicles are validated, so that you've got a level of confidence. And I think it's important that members of the public have that level of confidence as well, that actually, whatever vehicle they're getting into or service that they're using, there is that sort of consistent level of safety.
Okay, thanks, Camilla. Let's go to Tim. Tim next, still on the same question. Tim from Myra.
It's getting increasingly challenging. I think it's all good points so far. Most of my kind of talking points covered. So I guess the kind of summary of it really is just the fact that it's going to be a bit of all of these things. So it's very much the multi-pillar approach that's being talked about. I think there does need to be something which is defined and fairly consistent to give that kind of basic oversight and consistency across the board. We recognise, as Ian commenting on the need of simulation to give kind of broader coverage. So I guess the third pillar that's not been mentioned so far is perhaps also including some real world testing, just picking up on that point about actually the practicality of orchestrating some of these complex scenarios. It may be that a road test, whilst it's not going to be fair, every road test is different, it encompasses that kind of real variability. And with a limited amount of exposure, you actually get quite a lot of real meaningful evidence.
Okay, thanks, Tim. And actually, Tim, if I may stick with you actually for the second question to start us off on that one. Think about statistical performance goals. Do you think they're needed in addition to the behavioural requirements? And if so, how should this be assessed? Very difficult question.
Yes, I'll certainly try to tackle the first part of that. So I think it's kind of interesting building on the presentation, particularly by Siddhartha a moment ago. So you talked about behavioural requirements. I think the thing to bear in mind is I kind of almost see it as like a giant matrix. You've got all the things you want to do and all the scenarios in which you might need to do them. And obviously that's a kind of really kind of huge multiplier of all the different kind of permutations that might be encountered. So when we talk about statistical performance methods, I think the thing, or measures rather, the thing that I would like to kind of draw some attention to is there's two ways of looking at it. So first of all, if you define that kind of big problem space, there's the statistical measure of how well you've covered the potential variations that exist within it. And actually, I think the industry is doing quite well at the moment, and some of the projects we're talking about in putting some actual meaningful good practice in place and some good metrics. A much harder question, though, is how well did you define that problem space in the first instance? Unfortunately, not only do we need to be able to bound that, we need to be able to put a measure to that as well.
Great, thanks, Tim. Zane, could I go to you next, please?
Yeah, I think we see it from the second part, really. How would you evaluate the statistical goal? And if you can't measure against the statistical performance target, the value in defining it is much less. And this is quite challenging, whichever way you do it. You either run in simulation, but simulation needs to be extremely high fidelity, and you need to cover an awful lot of the test space to have this kind of confidence in the statistical results that you get from that. And you can't target the edge cases, because a lot of time the value of simulation is that you can focus on the complicated and unusual cases, but then at worst you completely lose any statistical validity of the results. But at best you need to perform a complex operation to get those statistics out of it. So then the other alternative is to do it in a real world deployment. But again, you hopefully your system is safe enough that you won't get these high severity collisions happening during a deployment even of 3 months. So perhaps there's ways around both of these. And in terms of the real world deployment, perhaps you can use near misses and other failures as a proxy, and use those to extrapolate the incident rate for higher severity collisions. But going back to the first side of it, yes, we do think that it would be really valuable to cover more of the dynamic driving task if you did have both types of requirements, both the statistical targets and the more concrete specifications for performance.
Okay, thanks. And Camilla, maybe you'd share your thoughts, please.
Yeah, I was interested in what Zane was saying there as well, actually, about the accident statistics and near misses, and being able to use that information in terms of performance, but also relating back to safety assurance. Typically, you assure safety of things that go wrong most frequently, and having that sort of data as a metric would really help us in terms of safety assurance and trying to pinpoint actually which are the areas that we really need to focus on when we're doing our testing and our assurance. And indeed, sort of going back to the first question about simulation and those scenarios, which are the ones that are the sort of most critical scenarios that we need to test, like during safety assurance. But in terms of performance metrics as well, I think looking at the simulated environment and real world testing and understanding how well your simulation is compared with the results that you get sort of in your digital twin, if you like, and your performance of your vehicle in the real world compared with simulation.
Okay. Thanks, Camilla. And let's go with Matt next from VCA.
Yeah, I think for me the simple answer is yes. I think we're asking AVs essentially to be safer than humans, and it may not be possible in every individual scenario to prove that, but overall, that we hope they will be, or we want them to be, and so a statistical goal is important to prove that they are safer than, or as safe as we want them to be overall, rather than just case by case. I think, picking up on what Zane said about doing this sort of in service or in real world, I think what's problematic is it'll take a very long time to gather enough data to get these statistical measures, and the software will have changed considerably during the course of gathering that data. So I think perhaps the evidence we gain from the statistical measures will tell us more about the developer and their development process than it might do about the individual ADS at any given point, because those statistics will be based over a progression of that ADS over time rather than a particular version of it. But of course, assessing the developer and the development processes is a fundamental part of what we'll be doing in approving an AV, as well as the specific implementation.
Okay, great. And Ian.
Yeah, this is a great question. And I think, as Tim said, being the last person to answer the first question, many of the sort of important points have been mentioned. And like, I think it's worth mentioning that RAND have released, I think, 2 like 80+ page reports on this exact topic, and like it's lots of really smart things that they say. And I think the one that we haven't talked about is, well, okay, you can decide if you want to measure your statistical safety performance against humans or against some sort of like independent of human standard. And if you do it in humans, well, what is an average human driver? And like, what is the average accident performance on your actual ODD? You know, like, you know, you will have very different accident profiles in urban scenarios as you do in highways and so on. And so you actually get like a different target that you have to meet if you want to naively say, well, I'm going to be twice as good as humans on average. So even figuring out the statistic to compare the statistic that we don't know how to calculate is something we don't know how to calculate.
Great, thank you all. So let's move on. I think I'll address this one to Camilla first, if I may. So thinking about, or let's say making an assumption that there might be some kind of a ADS licensing scheme. Do you think it makes sense to sort of mandate a trial period of, I don't know, say 3 months as a trial deployment prior to actually issuing a license? Do you think that's a reasonable action?
Yeah, well, I don't know whether 3 months is right or whether 6 months or a year is right. I think it's going to vary so considerably between different developers and different vehicles that really it's about ensuring that you've got that level of evidence that you need to demonstrate that your vehicle does what it says it does, that it operates safely within the ODD, and that you've got the evidence to support sort of the capabilities of the vehicle and a good understanding of what the limitations are. So I'm not sure that it's about a specific time period of sort of running about and trials. I think it's more about what evidence you've got and how you can demonstrate that, it's safe enough to be on road.
Great, thank you. And Matt, anything you'd like to add to that?
Yeah, pretty much agree. Yeah, with everything Camilla said. I think that really deployment of AVs is almost an ongoing trial period, because there will for sure be some element of continuous monitoring and reporting back to the authorities. So even 5 years down the line, that this kind of continuing to evidence that the deployment is safe will still be ongoing. I guess the flip side maybe is that we might want to have a period where the deployment is small and to gather that body of evidence before authorizing a larger deployment or a larger number of vehicles. And that's where a specific time period could be agreed, or a number of miles need to be driven before that can be expanded. But yeah, as Camilla said, I'm not sure that the time period would necessarily be fixed. I think it would be situation specific.
Yeah. Okay, thanks. Ian, your thoughts?
Yeah, I was nodding along with what Matt said there. Like, I think that's absolutely right. And like, if you glance across the Atlantic, you'll find that like it's actually sort of what's happening, right? So Waymo are starting with, there were safety drivers in Phoenix, and they had a very small constrained geographic ODD, and then you remove safety drivers and you gradually expand it. And I think like in practice, you'll find that like the manufacturer themselves is as interested in this sort of incremental like trial deployment and until the business becomes mature enough that this question is irrelevant, right? So I think this sort of continued incremental trial period where there's a lot of communication between the relevant parties is probably how things will land.
Okay, great, thank you. Just conscious of the time, so this will be the last question, and I think Ian, if we can stick with you, I'll let you answer this one first. How can V&V be balanced against? So I guess robust V&V be balanced against the need for near constant software updates.
Yeah, this is another tricky question. Like there's a lot of different like variables associated with this, because not every like software update is equal. And one category of software update is purely aesthetic or whatever, changing the brand. And another is like an operational design domain extension, which is a much more serious thing. Another could be, fixing a bug that was discovered in service. And there's probably going to be different types of like proposals for how you go and extend that. And there's probably a category in between that is something like, you know, performance or comfort improvements or something like that. And I suspect that we will have to find a sort of different mechanism to find a way to like accept these different styles of releases. And in practice, a lot of these systems are very modular. So you will find that in theory, it could be very serious to release any type of software update. In practice, less so. But I think we just need to find a way to make sure that there's good transparency between the developer who is like providing these updates and any sort of regulator that needs to decide whether or not they need to review it in any sort of like particular way.
Okay, thanks, Ian. And Tim, I'm interested to hear your thoughts on this. I think before we draw to close.
Yeah, thank you. So I very strongly agree with what Ian was saying, really. I think not all updates are going to be created equal. But I think the key thing from my side is that there's no kind of justification of why we would want to reduce the threshold for validation in a kind of later update. So it really is how well you can kind of compartmentalize and enforce those system boundaries to be able to make an argument that other parts of the systems haven't been affected. So yeah, obviously that kind of fits, I think, with the methodologies that are being developed around things like functional safety. So progressing down that front is the logical way to do that. I guess the wild card I just kind of throw in as something, maybe a takeaway thought, is the idea of actually running additional in-service validation routines. So this is something that's actually come up as part of a discussion around cybersecurity as well. So if you assume that the world around you is changing and potentially your system is changing for intended and unintended reasons, then actually it's desirable to have something running live in the vehicle to have an oversight.
Great, thank you. Okay, so we are rapidly running out of time. I wouldn't let people get away on time. So yeah, once again, thank you all very much. Again, I've been a really interesting and informative Q&A session. So very much appreciate your time joining us today. I think I'll now hand back to Zane, who's going to close the event for us. Thanks again.
Right, am I unmuted now? So thanks again to our panelists. So we've had an interesting day today with our 2 panel sessions, and I think I'm actually cautiously optimistic. From the first session, there's a consensus that separating the perception and decision-making parts of an ADS is a sensible and reasonable thing to do, and that's really useful for us thinking about potential regulatory applications. And in the second session, in the panel session just now, I think there's also a consensus, albeit a slightly split, a less concrete consensus, that a little bit of everything is needed as part of an assurance process. There's no one single method or tests type that will provide the confidence we need in the safety of systems. Yeah, and Siddhartha's work on scenario generation is extremely relevant to this. We're very much looking forward to being able to show practical application in some of the work that Rob is leading. And this also aligns very well with the upcoming Law Commission consultation. I think there's a slightly different viewpoint that the CertiCAV project is taking, and that the Law Commission, obviously from a legal perspective, and these two complement each other very well. So what happens next? This has been the final engagement consultation workshops that we're running on CertiCAV, but we're still very interested to hear from you. So please do send us comments via email. We're happy to have video meetings if anyone wants to request a meeting with us. And we are still running an advisory group for the project. So if you're interested in being part of the advisory group, again, please drop me an email. The project only has a few months left. We have to deliver at the end of March next year the project report and the software toolkit. But one thing that we are planning to do is to have another webinar, probably in March, that will just provide an overview of our findings at the end of the project. Okay, so with that, I would like to thank all our speakers today. I'd like to thank everyone else involved in